Let's start by understanding immunity. Basically, immunity is our body's natural defense system that protects us from harmful microbes. Think of it as a shield that keeps us safe by recognizing and fighting off anything that could make us sick. This protection is essential because it helps maintain our health by preventing infections and diseases before they take hold. So, what exactly is immunity? The word comes from Latin, meaning free of burden, which is fitting because immunity frees us from the burden of infections. Its main job is to stop or limit infections caused by harmful microorganisms. But immunity goes beyond just infections. It also reacts to any foreign substance, even things like mutant cells that might turn cancerous. In other words, our immune system is constantly on guard, protecting us from a wide range of threats. There are three main types of immunity we should know about. First, innate immunity is what we're born with. It acts fast and provides general protection against many invaders. Then there's adaptive immunity, which develops over time as we encounter diseases or get vaccinated. It's more specific, targeting particular threats. Lastly, passive immunity is temporary and comes from another source, like antibodies a mother passes to her baby. Each type plays a unique role in keeping us healthy. Let's dive into innate immunity and its key features. This immunity is with us from birth, offering a broad defense that doesn't target specific invaders. It acts quickly, but doesn't remember past infections, so it can't improve its response over time. Also, innate immunity can vary between different groups of people. So it's like a general guard that always stands ready, but doesn't adapt or learn. Innate immunity protects us through several components. Mechanical barriers, like our skin, physically block pathogens from entering. Chemical barriers involve substances that neutralize invaders. Then cellular factors include immune cells that attack and destroy harmful microbes. Finally, inflammation directs resources to infection sites to help fight off threats. Together, these mechanisms form a strong first line of defense against infections. Now, adaptive immunity has four main features that make it special. First, specificity means it targets particular antigens precisely. Diversity allows it to recognize a wide range of threats. Immunological memory lets it remember past invaders to respond faster next time. And discrimination ensures it can tell the difference between our own cells and harmful ones, preventing attacks on ourselves. This system develops over time and improves with each exposure. Adaptive immunity comes in two main types, humoral and cell-mediated. Humoral immunity uses antibodies to target microbes outside our cells, while cell-mediated immunity relies on sensitized T cells to attack microbes hiding inside cells. This division lets our body tackle infections both in the bloodstream and within infected cells, providing a comprehensive defense. Comparing innate and adaptive immunity reveals important differences. Innate immunity acts quickly, within hours, using barriers in cells like phagocytes to provide general protection. Adaptive immunity takes days to develop, but offers a targeted response through B and T lymphocytes, producing antibodies and effector cells. This timeline shows how our body uses a layered defense strategy: immediate general protection, followed by a specialized, stronger response. Looking closer at their differences, innate immunity is nonspecific and inherited, providing immediate but less powerful protection without memory. Adaptive immunity, on the other hand, is highly specific, develops over time, and remembers past infections to improve future responses. It can also cause allergies, unlike innate immunity. Understanding these distinctions helps us appreciate how our immune system balances quick defense with long-term protection. Active immunization is a process that helps our body build long-lasting protection. When we receive a vaccine, it introduces antigens that stimulate our immune system to create memory cells. These cells remember the threat and prepare our body to fight it off in the future. This artificial induction mimics natural infection, but without causing diseases, dramatically reducing infectious diseases, especially in children. An ideal vaccine has some important characteristics. It should provide lasting immunity, so protection doesn't fade quickly. It needs to induce both humoral and cell-mediated immune responses to cover different types of threats. Also, it must avoid side effects like autoimmunity or hypersensitivity to keep people safe. Lastly, being cost-effective means it can be produced and delivered widely, making it accessible to more people. These qualities ensure vaccines are both effective and practical. When deciding between vaccine types, it's important to weigh their pros and cons. Live, attenuated vaccines usually give lasting immunity and mimic natural infection routes, leading to a broad immune response. They're economical, but carry a small risk of reverting to a harmful form. Killed inactivated vaccines are safer and generally cause fewer side effects, but provide shorter immunity and require injections. They can also be more expensive for mass use. Understanding these trade-offs helps in choosing the right vaccine strategy. Passive immunity works differently from active immunity. It involves transferring ready-made antibodies and lymphocytes to someone, offering immediate protection. However, the recipient's immune system doesn't actively participate, so this protection is temporary and fades as the antibodies are metabolized. This mechanism is useful when quick defense is needed, like for newborns or people exposed to certain diseases. Herd immunity is a powerful concept in disease control. When enough people in a community are immunized, it creates a barrier that prevents disease spread, protecting even those who aren't immune. Achieving this requires high vaccine uptake, usually over 90%. Active immunization is essential for building this community protection. Ultimately, herd immunity aims for disease eradication, stopping infections from circulating at all. Now, let's put your knowledge to the test. Can you name examples for each type of immunity? Think about natural passive immunity, like antibodies a baby gets from its mother. What about natural active immunity, which develops after recovering from an infection? Artificial passive immunity involves receiving antibodies from another source, such as immunoglobulin shots, and artificial active immunity comes from vaccines that stimulate our own immune system. Take a moment to consider these examples.